All right, next up, we've got a Claisen condensation, which is very similar to our aldol addition reaction. So let's check it out. We've got some kind of ester here as opposed to just a regular ketone or aldehyde. And so what we're going to add here is some sodium alkoxide and then some H3O plus. In this case, your alkoxide that you add, whatever R group you want to add here is whatever R group you already have. That's to help prevent any transesterification reactions from occurring. So if you have like an ET here, add ethoxide. If you have a methyl there, add methoxide, so on and so forth. So we have this proton, which is slightly acidic. We've got our OR minus coming in, acting as our base to form our enolate. And then it's just going to react with itself, right? Same as in the aldol reaction. Now, the difference here is that this bond can kick back down, and now we've got a good leaving group, this OR. We can then kick that one out instead. Right, so as where before in the aldol reaction, we'd be left with an alcohol, this one will kick back down and kick off its alcohol or ester group, right? And then after that, we have this type of compound right here. The thing that's important to recognize here is that this hydrogen is quite acidic. And so we're going to have some base left over or regenerated from our last step. And so this will go ahead and do an acid-base reaction. And if you think about this negative charged carbon, it's actually very stable because it's conjugated with these two oxygens. So that negative charge is spread out over 3 atoms, 2 of which are oxygens. And so this intermediate is actually very important to the reaction. And this reaction wouldn't happen if this intermediate could not be formed. And so that's where your reaction essentially ends. Then we just do an acidic workup, right? Just some H3O plus, which will just reprotonate that carbon and make the compound neutral overall. And then we're left with our product. And so, right, because this is a key intermediate right here, and because we already removed 1 proton, our starting material for this reaction must have 2 protons, right? So you have to have 2 protons here in order for this to react. So must have at least, you can have 3, but you can't have less than 2, at least 2 alpha protons. You can't use hydroxide. If you use hydroxide, then you'll just get hydrolysis, right? Your ester will turn into a carboxylic acid instead. And when you do use your alkoxide, it's generally, you want to use the same one that you're using in your reaction. Same as starting material, right? So if you're starting off with some kind of ester, whatever R this is, that's the RO minus that you're going to use.